Finally, a project that I can shoot a video of and make public for all of you to enjoy. Oh man. It's a beautiful Sunday afternoon, and since we got to work like 6 days, 7 days a week, went out and went playing this morning with my new little toy here. One of about 15 I got. Chill out over there, big truck. Okay, we are here this afternoon to talk about this guy. We don't know who it's made by. Looks like somebody wanted to make it a rebel flag or something, some kind, but it got the wrong colors to it. This is black, not blue. There's no stars. General Lee theme, something or other. I don't know. So we've got the unknown manufacturing of amplifier, and we got ourselves an unknown circuitry here. The board down in the corner says a gray electric 500 right down in here, right printed on the board. Yeah, so I'm assuming this used to be a gray and then somebody modified it a little bit. Well, I am of the conclusion that we are full of old, cold, dead solder joints. I'll show you what I mean here. Let's get in here close. Let's take a look at it. There's a lot of room for improvement in this box. So we can clearly see here, this is a gray 500. Now this has got MRF 492s in it, which I don't have any more of. I don't think I gotta go look in the drawer per se. But there's a lot going on in here. It's got a sideband delay built into it over here on this switch, right here. But it's Class C. So it means no sideband. This is the gray combiner system and splitter system, but it's also got the gray low, medium, and high system. Now, my opinion is, and this guy is completely turned me loose on this box to do whatever I want, is that we get rid of this whole voltage divider setup over here, make it a straight drive so then he can hit it with a modern radio like a Striker. First thing I want to do is I want to get rid of this. So in the day, that on-off switch actually used to do something. They expected 100% of the energy potential for the amplifier to go through this switch. So big power wire up to crap owl little switch that can't carry more than about 25 amps. And then we're going to run this through a little tiny bar over here. It's a little tiny shmoo of a lead. And then in theory, this transformer should have another jumper coming off it going down to this trace, and then we're going to energize that trace. But I am not seeing that jumper. And I'm just wondering if this is somebody's idea of a project or what the deal was that's going on here, because I don't see any 12-volt source current going down to the second bank of transistors here on this 2-pill stage. So we're going to have to take a quick look at it, but we got to energize it and we got to run it. This combiner being all burned up leads me to believe the possibilities are that we have some problems with the transistors. But if they don't have any power, that just means these two transistors here would be turning on and these two would be off. So let's take a quick look at it and see what we can figure out. So it's kind of like right there in front of me. There's this wire that goes between the two, which is horrible. This is like the worst way we can do this electrically. I'm sure it works, but I'm sure it's not very safe. I'm afraid to look to see what's in here underneath these little nuts. We're going to ignore that for a minute. And strip these wires back here. Let's grab my handy dandy little bench wire extensions. Man, it got hot here yesterday, at least for us out here in Idaho. It's pretty early in the year and we're already over 100. Got the feeling this is going to be an interesting summer as far as heat is concerned. Okay, because electrons flow from ground to hot, we're going to go ahead and hook up our ground first, always, even when doing jumper cables, boys and girls. No sparky spark. That's a good thing. Oop. We got LED indicator. Nothing over here for our sideband delay. Let's take a look on how it runs. Hook this up to antenna. And then we'll tickle her input hole here lightly. We'll use a 2950. Oh, that's no good. So at least to make sure we got the one in the tight. Okay, there's two. We got two tight. Now, okay, so we are on 12 volt. First, we're going to test our ability to talk through the box. See if that's something that we need to address. Obviously, we are going to have a major power wire overhaul inside of this thing. So, amp off. Hello. Really? Not a goddamn bit of freaking pass through here. Hello, hello, hello. Hello? None of my meters are showing me doing anything here. Hello? It's showing me a watt going forward. Hello? Really? Hello? Boys and girls, I think I got myself some technical difficulties with my bench radio. I shall return. Now, that's some frustrating shit. This is easy to take apart. It's a friggin' nightmare to get back together. And when I pulled the mounting bracket screws out, it just fell out. Had to disconnect the power wire, but 5-watt slugging forward. Hello. I think the damn radio come unscrewed from the jumper that goes to a bird meter. I think I just took all this apart for nothing. Son of a doodly wet fart. Son of a gun. Well, that was an easier fix than I thought it was going to be. I thought for sure I'd been there totally dinking around with finals or a voltage regulator or something. Nope, just loose coax connector. Which, thank God that's all that was. Okay. Let's establish a baseline here for everybody. 1,000 watt slug and peak, 1,000 an average bird, whatever. And 5 watt slug in reverse. Okay. Now, I got the FLIR fired up. Let's see what we get. Hello, 1 2. Hello, 1 2 1 2 1 2. Hello, 1 2. Hello, 1 2 1 2. Hello, 1 2 1 2. Hello. Well, this isn't teabag at all. Hello. Almost 400 watts on 12 volts. We have no blown pills. Yes. Now all we got to do is go in here, clean up this gobbledygook, and make it better. First thing I want to do is I want to get rid of this stuff. The switch will still be on and off, but I'm going to use it to cut the power on and off for the relay. And we're going to make this a direct feed for the positive wire, which will help tremendously on how this works, first and foremost. And then the second thing that I want to do is I want to get rid of all this high, medium, and low and make it a high drive amplifier. So you can put like a 50 watt radio in it if you wanted to. And you don't have to worry about burning up any input resistors. Our input Schwer isn't really all that bad. So yeah, we'll see what it looks like after we bypass all of this gobbledygook here. And then we'll retune things for its maximum output. And we're going to replace our power wires with something that, well, resembles power wires and not chicken boogers. So this is our power wire. This is what controls our relay board. And here's our on-off switch. I'm trying to buy a bunch of burn mark. So I'm going to remove this jumper, remove this jumper. I'm going to create a pad for this thing to solder to our combiner and our splitter, our combiner and our resistor. This is how they're tuning the amp, is this little disc capacitor. So we'll move it, we'll probably put it over here between, oh no, wait a minute, they're using this disc capacitor to charge the indicator light, I apologize. This is how they're tuning the box. So we've got this cobbled together mess of capacitors here to act as a filter circuit so that we don't have any RF feed through this wire and screw up our keying circuit. Now I'm looking at this a little bit closer on camera. It's got capacitive inductance on the output. There's quite a few little things in here that I got to change. We're going to bring our ground. We're going to tie it to this distribution bus. I'm going to bring the positive wire in. We'll create a distribution bus for it. We'll feed off of that. We'll probably put it over here someplace. Feed off of that and feed these two transformers. Then I'll run another piece of wire over here to run to the switch, and then replace this lead here, going back to the board to run the amplifier. So now the on-off switch, instead of passing all the current and acting like a big bottleneck, is going to not be present, and all it's going to do is a passive job. And then I'm going to figure out what I want to do with this over here. Okay, so it's been radically modified since it was here. Since the last segment that you've seen. We came in and changed out our power distribution. As I said, I wanted to make it so that this switch, all it did was control the voltage that goes to this board that controls our transmit and receive. So we modified that, and we made the transistor straight fed. That'll help make it run a little bit cooler. Now these are MRF 492s, which are about 100 watts a piece-ish, peak power-ish, so they're about 60 average, 80 average, somewhere in there, at 12 volts. 14 volts, we're going to get a little bit better response out of it. I added flybacks to the situation, and then I started running it. And I couldn't help but notice the phenomenal amount of harmonics that this box was producing. I mean, it was literally every 10 kcs. So I had to go on the hunt for why. And I played with all the different capacitance levels at all the different sections of this box, all the output sections, everything. And I couldn't get the harmonics to come away. So I thought, well, and I also couldn't get the input to fall down. So I took a turn out of each one of the input transformers, just kind of shooting in the dark to see how the circuit would react. And the input dropped way off, but the harmonics stayed super present, and I could not add enough inductor or add capacitance in the right circuit or into the circuit to make the suppression of the harmonics. And I'm like, so there's got to be something that is secondary to this thing that is making the harmonics be so prevalent. This is our output combiner. Now if we stop and we look, we go to a manual here. If we stop and we count the number of turns on this, it's got 5 turns. And it's obviously been burned up many times before. I don't know what this material is that's inside this combiner. I don't know. I didn't like that. And then this is obviously like a piece of type 43, and it's got 7 turns on it. I did not like that. So I removed that, and I used type 61 on the output, type 61 on the input, and I did the standard 2-to-1. So 2 passes to 1 port, 2 to 2-1 port, and all the harmonics fell out. I was like, shut up. And the input hopped up just a little bit. So I was able to add a 3rd capacitor. They've got 2 capacitors here balancing the circuit. And these have to be within 1% of each other to make this work, otherwise it will cause harmonics. Do not try to tune like this. This is a very not suggested way to tune, adding capacitance on the splitter. Because if you notice on the output over here, we had to modify it, there's no capacitance on it. This will lend itself to creating harmonics, this form of tuning. What happens is this capacitor has a slightly different value than this capacitor, this one vice versa, and so the RF is going to travel differently, and you end up having a little bit of coupling that takes place here. That's why I see this in a lot of other guys' boxes, and I go, whoa, I freak out. This is the only way I could get this particular circuit to lay down and actually operate appropriately. On the output side over here, I created a new combiner pad because the one that was underneath it, there was only 1 port for it. So obviously it had been burned up multiple times. So I went and I got myself one of these things. This is straight up some skullcracker technology right here. This is from my teacher and my friend, Mr. Minister. He created these for his skullcracker boxes so he could put his combiners and the resistors up on these little phenolic boards. I have little standoffs that screw into the heatsink, so it could stand up like this and then have his combiner. So like this 4-pill section, this 4-pill section, and then he could do immediately the combining of the 2 4-pill sections together. So, or 4-pill, 4-pill, and then combine. That makes sense? It just, like this 4-pill unit would use just this much of the board. Well, that's what I did. I trimmed this off, and then I cut it in half, put some double-sided stick tape on it, and replaced the burned up trace that was on here with something that was 1, raised and insulated, and 2, new. So I didn't have to worry about that arcing over. We got all that out of the way, put the flybacks in here, make it so it takes a little bit more drive, but still honestly, this is about a 25 to 30 watt drive box. There's no more low, medium, and high. And what they were doing on the low, medium, and high switch here is they were burying the horrible input behind a resistor. Really common practice back in the 80s. It didn't really matter what the input looked like. Once you ran it through a resistor that goes to ground, like this one here, and there was another resistor that went from this port to here, so you'd have high, which was directly passed through, but then it'd always have this resistor in line coupling to ground, creating your 50 ohm load, so therefore it'd give you a false input, and hence the reason it's so burned up is because this is what represents your input. Then they'd have a low or medium and then a high. Okay, so low, medium, and high, this way being all the way high, medium, then low. They had different stacked resistors. I didn't see any point in leaving the resistors in there, so I took them out. That's okay. They didn't look so grand on the band either. They'd seen better days. So now this is a straight input, straight 4-pill with MRF 492s in it. So in all fairness, when we did our bench line test at the very beginning, let's go ahead and we'll turn the amp on. We used a 1000 watt slug and peak, which is this one here. 1000 in peak, 1000 in average or bird, and our 5 watt slug and reverse back from our bird 10,000 watt dummy load. We used our 2950 on 12 volts. And at that time, we were seeing about 320 watts worth of peak power out of the box. Hello. So we're seeing about 350, a little bit of an improvement there. Hello. But this is what I like up here. This is what I enjoy. That's a 5-watt slug in reverse between the amp and the radio. Hello. Hello, audio. Stupid low. And our output signal is actually all on frequency. It's not all over the band. So let me reach down here. We'll turn on our big 1,000 amp power supply. Now we're going to sit back and we're going to wait for our supercapacitor bank to absorb some of that energy. And this is on 14.5 volts. Hello, 500 watts. Exactly what it should do. Hello. Once again, input tune. Hello. Really low. Really low. Turn the radio or the amplifier off. Hello. There's our 20 watts of drive. Let's talk about our pass-through tune. Hello. Perfectly happy as well, which is good. That means the RF can now come from our radio, pass through our box and out to the antenna, and then the signal from the antenna can pass through the box to the radio smoothly. Hello. Hello, audio, 1 2 1 2 1 2. Hello. That's the way she's supposed to work. This is spectrumally as clean as I can make this without doing radical modification to it. There's just a lot of stacked capacitors on this thing. We modified the power wire so it comes directly into the ground bus instead of over here in a corner and it's having to work its way through all the different little cut traces and stuff. Coming directly in, going directly to the transistors by upping our power wire from the little blue shit that was in here and bypassing all of our power wire for all 4 transistors went directly through this little wire here. And then I couldn't help myself. I was very curious about what was inside of these little nuts that were on the end of things here. I took about 20 minutes and I pulled all the electrical tape off of this particular splice, and we have ourselves a chicken pooed together connection that isn't soldered the whole way. And then inside of this ball of electrical tape love, here's the ground side. This is all around the positive side. We have our big power wire, and then it goes to an aluminum end splice, like what you use for 110 volt in your house, right? And inside of an electrical panel someplace. Then they get a good 1/16 of an inch of butyl around that, and then they had 3 layers of electrical tape. So we're going from big wire to small wire through an aluminum block, and then small wire to halfway soldered together butt splice. Not even 2 inches from that. So we took all that out of line, cleaned up everything on the inside. This thing works perfectly the way it sits. You got on off. You got your sideband delay over here. This is sideband delay, this is on, this is off. And the high, medium, low switch has been abandoned. I went ahead and put a plastic body insert in the front of this thing. I'm done. This thing's done, it's ready to go home. It's gonna last another 15, 20 years. Do not overdrive this. Try to keep your drive under about 35, 40 watts, and this will last you forever. On that note, gentlemen, I'm going to take off. I got a bunch of stuff I've got to get ready to do. And I think the next video I shoot is going to be from the road, maybe someplace. We'll see. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook, BBI Amps the group. Come join it. It's open to all. believe me, if we don't want you there, we're not going to let you in, or we're just going to kick block and ban you. So to the hater instigators, be forewarned, we're not scared. I'll see you, gentlemen. Big shout out to Siglent. Big shout out to Excess Power. Appreciate you guys. I'll see you. Bye-bye.